Hello and welcome to Functional Skills Maths. Today in this session we are going to be looking at the perimeter and area of triangles, which is a level 2 topic. I'm just going to share my screen with you now and we'll look at this together. So by the end of the session you should be able to calculate the perimeter of a triangle and the area of a triangle. So perimeter. Again, just to remind us what is perimeter? Perimeter is the distance around the edge of a shape. So what we're doing when it comes to triangles and the perimeter, we're trying to measure the distance around the edge of the three sides. And to do that, all we do is we just add up each of the individual lengths. So if we put some lengths on that, let's say the height is 5 meters, the longest side of the diagonal is 12 meters, and the base of the triangle there is 10 meters. What I do is just 5 plus 12 plus 10 equals 27 meters. So that's the process really for working out the perimeter of a triangle. In functional skills maths, there won't be any missing sides where they don't give you the measurement, except in the case of isosceles triangles, which we'll look at on the next page. But for now, have a look at the example here on the left of your screen, is the blue triangle, and give yourself a moment just to work out the length of the perimeter of that blue triangle, or just pause for a few moments, give you a little bit of space to think about that. Okay, so hopefully you've been able to work out that the perimeter of the blue triangle is 390 centimeters. Got 100 plus 200 plus the 90 gives the 390. So all the measurements were there. It's nice and straightforward. Now on the green triangle, this is a triangle where they might not give you all the measurements. So you can see, for example, they've given you the left-hand side. They've also given you the base of the triangle, but we're not told what the right-hand side of the triangle is. But thankfully, we can see that we've got two black lines on both the left and the right-hand sides of that triangle. Now, what those lines mean is that the triangle is like a mirror reflection of itself, really. So we can almost imagine there's a mirror running down the triangle from the top straight through to the bottom, and each of the two sides on the left and right, they're a mirror reflection. So essentially, we can work out that it's the same length on one side as the other. It would also be the same angle, but we don't need to worry about that for now. So it's the same length. So essentially, we have 8 on the left, 8 centimeters on the right, and the 10 centimeters of the base. And so we can work out from that it's a perimeter of 26 centimeters. Okay, so just to recap there, the perimeter of triangles is fairly straightforward in most cases. As we see in the example on the left, all the measurements are given, and this is often how it is in the functional skills exams. Occasionally, they might present you with an isosceles triangle, in which case this will be indicated by the two black lines. And you just need to remember that they're a mirror opposite. So the length on the one side is going to be the same as the length on the other. Okay, let's move on to the area of triangles. So to work out the area, which again is the space inside of the flat shape, as a brief reminder. So in terms of rectangles, we're saying that it could be equivalent to the amount of carpet that we need to fill a room. In terms of a triangle, it's the amount of space inside of that triangle. So how much blue is there, in other words. Now, to calculate the area of a triangle, what we do is we multiply the base by the height, and then we divide this by 2. So just to reiterate there's a little bit of triangle language, if we can call it that. The base is what the formula uses, and it's essentially it's the bottom of the triangle. It's the base, and the height is what we might call the width, had this been a rectangle. So essentially, multiply the base by the height, and then divide your answer by 2 at the end. So in this case, it'd be 10 times 5, which is 50, and then divided by 2 gives us 25 meters squared. And important to remember that we're dealing with area, two-dimensional shape, so that little 2 needs to go in the top right-hand corner after the measurement unit. And formula is just up here. So base height divided by 2. This little notation here where I'm circling my mouse. BH divided by 2, base height divided by 2. So please write this down, commit it to memory. You will need it for your exams, and it will not be given in the exams either. So it's one that you do have to remember. Another way of thinking about it, if it helps, is to think of it as half of a rectangle, really. So if we look at this blue triangle in the middle of the screen, if we did the rectangle formula, that would be 10 times 5, or length times width. That would give us the area for, if you imagine a dotted line coming up around here, the whole thing. But because it's a triangle, it's only half the rectangle, and that is why we divide it by 2 at the end to get the area of just 1/2 of the rectangle or the triangle. Let's have a look at a few examples here. Remember the formula, base height divided by 2. I'll give you a few seconds to work these out. I'm just going to pause. Feel free to press the pause on your video and give yourselves time to work all 3 of these out. You can use a calculator if you wish, but you can also try and work it out by hand or without a calculator if you prefer. I'll pause now and we'll go through the answers shortly. Okay, so the blue triangle then, so we said the formula base height divided by 2. So we got 18 times 10, 180, divided by 2 gives us 90 centimeters squared. Okay, and then the green triangle, 70 times 200 divided by 2, so 7,000 millimeters squared. And finally, the orange triangle, 50 times 30 divided by 2 is 750 meters squared. Hopefully you've got all of those correct. If not, then just press pause again on the video and just go back and double check your workings out to make sure that you're happy with this method of working out the area of triangles. And just to recap then, in this short video, we've looked at how to calculate the perimeter of triangles and the area of triangles. Okay, so I'm just going to stop sharing there. If you have any further questions, then please ask your tutor, who will be only too happy to help you. And otherwise, for now, I wish you all the best with your functional skills studies.